All right, I want to welcome you to this worksheet. It's called Formation of Ionic Bonds. And we've talked a little bit about the fact that ionic bonds are formed when two or more atoms come together and are able to lower their potential energy by either gaining or losing electrons. Usually is one, but it could be more than one. But the important thing is that the elements that are involved, or the atoms that are involved, lower their potential energy to get to a valence number or an outer shell number of 8 electrons. That's the key. Now, we've also said that if the electronegativity difference between the two atoms is more than 1.7, that's the key number, 1.7, then the two atoms are going to form what we call an ionic bond. So let's take an example. Let's take sodium, for example, which we know has 11 valence electrons, or total electrons, but one of them is what we call a valence electron, and so we'll denote that one just like that. Now, chlorine has a total of 17 electrons, 7 of which are valence, and I'll pair them up just like this for a total of 7 valence electrons just like that. What's going to happen is that chlorine is much more electronegative than is sodium. It's on the right side of the periodic table, so sodium is a metal, chlorine is a nonmetal, and when we put them together, what's going to happen is that the sodium is going to lose its electron. It's going to lose its electron to chlorine, and chlorine then is going to have an octet of electrons. So sodium will have no electrons left in its outer shell, so it'll gain a charge of +1. Chlorine, on the other hand, will have gained that electron to have a full octet of electrons around it. It now has a charge of -1, just like that. And this is the basis for what we call an ionic bond. When this happens again and again and again, with cations and anions coming together to form this ionic bond, we have what we call a crystal. Let me write that for you. A crystal lattice. So a crystal lattice is just a physical form that contains both the cation and the anion, and they are involved in ionic bonding. So when you have that many times, if you, for example, look at a salt crystal under the microscope, within that crystal are millions and millions of these sodium chlorine couples, these cation anion couples, okay? So that's an example. Let's take a look at a couple of other examples. Let's take a look at this one right here. Lithium and chlorine. Now we know that lithium is on the right-hand side of the periodic table, so the left side, so it is a metal, right? So this one's a metal, and when a metal and a non-metal come together, the result may be, if the electronegativity is 1.7 or greater, an ionic bond. So what will happen in this case is that lithium will give away its valence electron, leaving it with not an octet, but a duet, which is just as good for lithium. It's going to have the same electron configuration as helium. And now chlorine has gained an electron, and it has now an octet of electrons. So let's take a look at what happens in the product side. Lithium, again, is now positively charged. It has 2 electrons in the inner shell, which I won't draw. And chlorine, on the other hand, has a full 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer shell. It now has a charge of -1. Now notice the +1 and the -1 cancel each other out, so the whole complex, the whole ionic bond, is what we call neutral, right? Now, when we're naming the compound, or writing the symbol for the ionic compound, we're simply going to name the cation, lithium, and we're going to name the anion, chlorine, but we're going to change the INE on the chlorine to chloride, okay? Just like that. So what we get then is lithium chloride. So this is the ionic bond called lithium chloride. Okay? All right. Let's try a harder one. Let's try oxygen and sodium. Now, we know that sodium has 1 electron to give away. Oxygen wants to gain 2. It has a valence of 6 electrons, right? Notice how I've not paired the last two electrons. So it wants to gain 2 electrons. So the way that this ionic bond is going to work is that both of these sodiums, these are the metals, are going to give their electron to the oxygen, just like that. And in doing so, they're going to gain a +1 charge. So sodium +1, sodium +1. Both of these atoms are going to gain that +1 charge. And oxygen, which now has the octet around it, is going to have a -2 charge. Again, notice -2 +1 +1. The entire complex is going to have to be 0, has a total charge of 0. And by the way, we call the complex of an ionic bond a formula unit. Okay, just like that. So you're not going to see a lithium and a chlorine in a single pair, nor will you see an oxygen with a sodium or a sodium. Again, it happens over and over and over again to form this crystal lattice that we've talked about before. Now, how would we name the compound? Simple. We take the cation, in this case it's sodium, and we take the anion, oxygen, and we turn the oxygen into IDE. So we simply name it sodium oxide, just like that. Now, why Na2O? Well, there's 2 sodiums. It required 2 sodiums to give away each of 1 electron on each sodium to the oxygen, so it's going to be Na2O. That's sodium oxide. Got it? Let's try another one. Let's look at this one, magnesium and fluorine. This time, magnesium is coming from the left side of the periodic table. It's the metal. Fluorine is going to be from the right side. This is a nonmetal. So fluorine requires 1 more electron to complete its octet, but there's going to be 2 of them because each of the electrons of the magnesium is going to go to one of these fluorines, completing the octet in each of these fluorine atoms. So what's going to happen to the charge on the magnesium? It's going to go to a +2. It's given away 2 electrons. Fluorine, on the other hand, is going to gain 1 electron each. So each one of those is going to have a charge of -1. What's the total charge of the complex? +2, -1, -1, 0. Let's name it. Magnesium is the cation, fluorine is the anion, so we're simply going to call it magnesium fluoride. Okay, magnesium fluoride. And that's how we name ionic compounds. It's just that simple. Why the 2? Once again, like in the previous problem, magnesium pairs with not 1 but 2 fluorine atoms, and that 2 reflects the fact that the magnesium is pairing with both of the fluorine atoms. Okay? All right, let's move on. Okay. This time we've got potassium and nitrogen. Now nitrogen is in the 15th column, 15th family or group, so it's going to have 5 valence electrons. 1, 2, 3, 4, 5. Notice I don't pair electrons until I have to, right? So I only have to pair these 2. And by the way, the 2 that are paired could have been on the bottom as they're drawn, or on the left, or on the right, or on top, or onto the right. Doesn't really matter. The point is we have 2 pairs of a pair of electrons that's bonded and 3 single electrons here. So how are they going to form an ionic bond? Well, potassium is willing to give away an electron, but nitrogen wants to gain 3 electrons. So it will require 3 potassium cations to make this happen. So this electron might go there, that electron there, and this electron right there. Okay? So what have we got now? We've got an ionic bond formed by 3 potassium cations, each having a charge of +1 because each one has lost their valence electron, and nitrogen having a charge of -3. It's gained 3 electrons. What's the total charge in the formula unit? +1 +1 +1 -3. Total charge? 0. The total charge must be 0. Let's name it. We have 3 potassiums, so we're going to call it potassium and then nitrogen. Nitrogen becomes nitride. Remember the IDE ending. And then we've got, for the formula, K3, because there are 3 potassiums, N. K3N then would be the formula for this particular ionic compound. And now let's take the last one. Here we have barium and oxygen. Barium has 2 electrons in its outer shell. It wants to give those 2 away. Oxygen is more than happy to oblige. It wants to get 2. So this electron might add on right there. that electron right there. And now barium has 8 electrons in its outer shell. It has a charge of +2 because it's lost 2 electrons. Oxygen has gained those 2 electrons. It's extremely happy now. It has a charge of -2. On the outer shell, there's 8 electrons now. 2 electrons have been added, so a charge of -2. +2 minus 2, total charge has to be 0. How do we name this compound, this ionic compound? Well, we'll take the barium ion, so we say barium. Oxygen becomes oxide, so it's barium oxide. And now we'll write the formula, BaO. It's just that simple. Folks, on the next video, we're going to be taking a look at covalently bonded compounds. So remember, in this video, that we're looking at atoms that have an electronegativity difference of more than 1.7, okay? If they have an electronegativity difference of more than 1.7, the cation and the anion have an electronegativity difference of greater than 1.7, then we're looking at an ionic bond. All right, I'll see you on the next video. Bye-bye.